Hello dear students, so this is Dr. Vijaya Babu. So in continuation with the previous lectures, so we are in mesh analysis. Okay, so we have solved the case 1 problems of mesh analysis where the problem will be given with only independent sources. Okay, so today's sessions will try to go ahead with the combination of both independent and the dependent sources. Okay, so now, so this is a problem, so which is given to calculate the value of Vx. Okay, has given the independent source as 24 volts, but the dependent source has given it as 4I naught. However, 4I naught is a voltage source because the notation is plus and minus. Okay, it's very clear. Now, so going ahead to solve this problem, as I said earlier, so whatever the unknown is being asked, so you try to eliminate that in the circuit and try to redraw the circuit and take the circuit in your control. So that means same thing I am doing here once again. So redrawing the circuit as this way. You have 24 ohms and then you have 4 ohms here. Okay, then finally you are having plus minus 4I naught. So 10, 24, 12 and 4I naught. Okay, so this is a circuit. So what is given? Now, so in this circuit, I think I have removed Vx and I naught also. But it is most important as I said in the earlier videos. So you should not remove the value of I naught. I naught compulsory you have to carry forward because I naught is a dependent parameter because this voltage source 4I naught, okay, dependent source depending upon that I naught. So you should not remove that I naught, otherwise you will be in trouble. Okay, so that means the unknown Vx that I have eliminated and take the circuit in my control. That's it. So I have took the circuit in my control. So going ahead, so try to identify the number of meshes. So go with the procedure of analysis. So identify the number of meshes. There are 3 meshes now. So try to consider the currents as I1, I2. All of them I am considering it as clockwise only. So I1, I2, I3. Now once you fix the currents, try to walk in the loops. If the current is with you, take it as positive. If the current is opposite to you, take it as negative and write the KVLs. So going ahead now. So I'm going ahead with the first loop. Okay, so first loop. So I'm here. Next I'm here. So I'm here. So I'm here. I'm touching the minus 24, negative terminal of the battery, right? So that means KVL in loop 1. So it is minus 24. Okay, then you are here and you are here, then you are here. Okay, then you are ahead of this 10 ohm resistor. So forget about this I naught now because we need to represent the currents in terms of loop currents. Okay, voltage drop in terms of loop currents. So voltage drop across 10 ohm plus 10 into whatever the current coming with you, you take it as positive. Current coming opposite to you, you take it as negative. So in the first loop, so you're walking at across 10, there I1 is with your I1 is your friend, it is with you, whereas I2 is coming opposite to you. So this is minus I2. Okay, so now I'll try to show with the black color. So now you are here. Okay, so you are here. So there is no drop across the conductor. It is a equipotential body. So going ahead, now you are exactly at the 12 ohms, right? So at the 12 ohms, if you clearly observe, okay, I1 is coming with you, but 12 is combination, 12, the drop across this 12 ohms is something depending upon I1 and I3. So 12 ohms is adjacent to first loop and the third loop, right? So that is why I1 current is coming with you. This is your friend now. Okay, but I3 current coming opposite to you, it is your enemy, so take it as negative. So this is I3. Okay, then same using the black color. So I am here, there is no drop here. So finally you have arrived, okay, at the last, the original position. So I have completed KVL in the loop 1. So try to cumulatively write all the I1s together, I2 together and I3 together. So 12I1 plus 10I1, 22 I1, then I2 minus 10 I2, then I3 is minus 12 I3 is equal to 24. It is equation 1. Okay, so similarly applying KVL, so I'll try to take the red color now. So KVL in loop 2. Okay, so now anyway you can walk, it's up to you. So I start here, I walk in this direction. So anyway you can walk. So now you are at the 24, try to write the drop across 24. So trying to write the drop across 24, 24 into, okay, current coming, the current I2 is coming opposite to you. Okay, so that means it is your enemy. So it is minus I2. Okay, then you are here, so you are here, so you are here, then you are here. Okay, you are here, so you are ahead of now 10 ohms. So when you are ahead of 10 ohms, so this is plus 10 into, check the currents. Current I1 is with you, but current I2 is coming opposite to you. So I1 is your friend and I2 is your enemy. Okay, so I have crossed the 10 ohms now. Now cross the 10 ohms. Okay, now I am here at 4 ohms. So 4 ohms actually it is adjacent to loop 2 and loop 3. So that is why the drop across 4 ohms is affected by I2 and I3. So 4 multiplied with, so check the currents now. You are walking right now. So when you are walking right, I3 is with you, but I2 is coming opposite to you. So minus I2 plus I3, because I3 is your friend here, I2 is your enemy. So you are crossing 4 ohms now. So there is no drop across the conductor. So finally you come back to the original position. So which is equal to 0. So I have applied the KVL in this loop. So bringing all the terms together, rearranging these things. So I1 quotients add together 10 I1 and I2 quotients add together. So there is minus 24 and there is minus 10. So minus 34. So minus 34 minus 4 minus 38 I2. Okay, then finally I3. So it is 4 I3. Okay, so is exactly equal to 0. So this is equation 2. Okay, so I have applied KVL in loop 2 now. Now I am going ahead in applying KVL in loop 3. Okay, so I'll try to use the violet color now. So understand clearly, KVL in loop 3. Okay, so I start walking. So in the same way, so I'll start from here. I walk like this. Any direction you can walk, it's up to you. Okay, so I'm here, I'm ahead of this source. That means it is minus 4 I naught. Actually it is a voltage source na, so it is a voltage drop, need not to be worried. Then you are here, you crossed the source. Okay, then you are here, then you are ahead of this 4 ohms. So whenever you are ahead of this 4 ohms, try to observe current now. Actually 4 ohms, there is the drop across 4 ohms is the effect of both I2 and I3. So I2 is your friend and I3 is your enemy. So that is why this is plus I2. Okay, I2 coming with you. Okay, but I3 is coming opposite to you. So this is minus I3. Okay, then you have crossed the 4 ohm resistor. Then you are here, there is no drop across the conductor. Okay, then you are ahead of the 12 ohms. So 12 ohms actually it is the drop across 12 ohms is affected by the adjacent two loop currents, that is I1 and I3. So whenever you are crossing this 12 ohms, clearly observe I1 is your friend and I3 is your enemy, because I3 is coming opposite to you. That means this is plus I1 minus I3. Okay, so then you have crossed 12 ohms. So there is no drop across the conductor. There is no drop across the conductor. You come back to the original position. So is equal to 0. Now bringing all the I1 quotients together. So 12I1. So this is 12I1. Then it is 4I2. Okay, so this is 4I2. And I3 quotients plus 4 and minus 12. So minus 8 I3 equal to 4 I0. This is equation 3. So if you clearly understand this problem comes under case 2 problem. The reason is that here there are 3 meshes are there. I have applied 3 KVLs. I got 3 equations, but these 3 equations will not sufficient to solve for I1, I2, I3 because the above equations variables are, what are they? I1, I2, I3, and there is one more dependent parameter I0. So there are number of equations are less than number of variables. So that is why this is a case 2 problem. Okay, now in such case compulsory you need to investigate the fourth equation here in this context. So once you investigate the fourth equation, then finally you will be having 4 equations and 4 unknowns. You can solve them. You will be getting all the values of I1, I2, I3 and I0. So I'll try to go ahead in investigating the value, the fourth equation. So where is the fourth equation? Consider this is 10 ohms. Okay, so this current is simply I0. Okay, so if you try to represent the loop currents here, okay, so if you try to indicate the loop currents, the loop current I1 is going this way. Okay, similarly the loop current I2 is coming upside. Yes or no? I1 is coming down, I2 is coming going up across 10 ohms. So now I think you can indicate I0 in terms of I1 and I2. That means the fourth equation simply I0 is exactly equal to what? I1 minus I2. So this is the equation number 4. Okay, so now the number of equations is equal to number of variables. So directly you can solve for I1, I2, I3 and finally I0. So upon solving, so we will be getting the values of I1, I2, I3 as I1 is equal to 9 by 4 amperes, I2 is equal to 3 by 4 amperes and I3 is equal to 3 by 2 amperes. And I0 is simply I1 minus I2, right? So I0 is I1 minus I2 means 9 minus 3. That means this will be 6 by 4 amperes. So finally you got all the 4 variables, that is the loop currents I1, I2, I3 and the dependent current, okay, parameter, that is I0. But the problem is not done now. So the issue is with the calculation of Vx, right? So now I try to copy separately the value of Vx. So this is a 4 ohm resistor. Okay, I'm going ahead finally for the calculation of Vx. So the Vx is something defined like this. This is plus minus Vx. Okay, now you try to take the loop currents. Here I3 is in this direction. If you clearly observe, I3 is in this direction. I2 is coming oppositely with I3. Now you need to calculate the value of Vx, right? So the value of Vx is exactly equal to, okay, so applying the Ohm's law, simple Ohm's law, 4 into current entering the positive terminal of Vx, okay, that should be plus I3. The current coming opposite to you is what? Minus I2. So the value of Vx will be 4 into, so this is I3 minus I2, that is 3 by 2 minus 3 by 4. Okay, so that is equal to, so 4 into, so LCM you can take it as 8. So 12 minus 6, so it is exactly equal to 6. So answer is exactly 3 volts. The value of Vx is how much now? 3 volts. So once you calculated the loop currents I1, I2, I3, Okay, you can calculate anything in the question that is being asked. So you can calculate current anywhere, you can calculate voltage drop across any resistor, that you can do anything. That is why at the first step I have removed the value of Vx, and then I have go ahead, I have took the circuit in my control, and then I have applied the mesh analysis procedure. I got the loop currents. Once I got the loop currents, finally I have calculated once again the original question. So what is that? That is the calculation of Vx. Okay, so this is usually the standard procedure you need to follow for such type of questions. Okay, so this is a problem, something combination of dependent and independent sources. Here the criticality is that the investigation of the extra equation. Okay, whenever the number of equations are less than number of variables, so you need to investigate the extra equation. That equation will help you to solving all the loop currents and the dependent parameters. Okay, so with this lecture I am concluding this. So if you are really liking these videos, just try to like them and subscribe the channel. Also you can comment so that we can do lot more videos on this. So thank you for giving this opportunity. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.